Hello and welcome again. When the global pandemic hit us in March this year, the IB was not prepared to generate an alternative assessment for students. Of course, they resorted to using teacher-predicted grades, historical data for schools, and data from students' performance on the internal assessment, or IA. Most, if not all, teachers around the world realized that this was going to be an inadequate and unfair means of assessment. But given the urgency of the situation and the fact that the exam was mere days away, no one was prepared to offer any alternatives. But since then, the May 2020 results have been released. First edition, a second edition, and it's now evident that that particular model of assessment is fraught with difficulty. But what alternatives exist? Is there another way for a teacher, a school, and by extension the International Baccalaureate to meaningfully evaluate a student's performance in chemistry using a 30-minute activity? One proposal is to get the student to appear live on camera, very much like how the IB oral exam is conducted in language. Get the student to appear on camera and give them a single prompt, perhaps a prompt like this, CH4, without even saying what it stands for, CH4. The student would then be required to know that that is methane, and then they would be given certain directions to follow as to how they're going to possibly present a mind map, a diagram, a chart like this one, or write a mini essay organized in distinct sections to cover as much breadth as possible from the IB chemistry syllabus. This particular diagram here is focused only on SL chemistry. So, to cover as much variety as possible, and for each topic that's explored, each distinct topic that's explored in the student's open-ended answer, the student is required to show some in-depth understanding of the contents of the IB chemistry guide. And if a student produces something like this in 25 or 30 minutes of open time, and when I say open time, I mean with being on camera and having access to textbook and notes. No access to the internet, of course, because on the internet, looking at the student remotely, it's possible to be chatting with someone else. So the observer or the invigilator looks at the student on camera, sitting at a desk, working with paper, pencil, textbook, a copy of the chemistry guide. So it's very much an open book assessment, if you will. But if the student doesn't have a strong command of the IB chemistry guide, if the student isn't really performing at the subjective descriptor for a 7 as given by the IB, then the student will not be able to produce a diagram like this, first of all. And in addition to that, they won't be able to clarify any of the issues that could follow from this when this diagram is sent to the examiner who is observing them, and a 10-minute interview follows up to clarify one or two issues. But in that 30 to 45-minute period of watching that one student, giving them the time to produce a diagram like this, a diagram, a chart, a mind map, or a mini essay, and then the examiner looks at it and selects one or two points for further exploration. At the end of that 35 or 40-minute period of time, the expert examiner should then be in a very good position to decide which of the subjective descriptors for sciences the student would fall into, whether it's 7, 6, 5, 4, 3, 2, or 1. So here now is a look at the specific question that I'm going to propose to my students. When I actually assess them, I'm going to give a range of molecules to choose from, or a range of prompts. In this case, methane is the prompt. Each student in my class would not necessarily receive the same prompt. Once they get the prompt, they will be following these instructions. Given a strict time limit, allowed to use whatever notes they want, stay on camera, and submit a final answer like this one. Once a student submits an answer that looks like this, with all of this information, with a range of points raised, and all of them seemingly related to the molecule that is the prompt. And that's, of course, very important, because knowing that they're going to be assessed in this way, the candidates could quickly just pull sections at random out of a textbook without knowing how to relate them to the prompt molecule. And in the post-presentation discussion, after this is sent to the examiner or the teacher, if there are any doubts about whether the student can explain all of this, then a 10-minute interview would follow, where the student is asked to explain things like, for instance, why do you have solid carbon here? Or how do you know that this reaction is exothermic? Or give me some more details on how you find this enthalpy of combustion. What's in this beaker? What is this? Is it a negative sign or is it a free radical? What kind of bonding do you have here? Why is it that you have the same tetrahedral answer for molecular geometry and for electron domain geometry? What is the role of a lone pair in determining the molecular geometry and the electron domain geometry of a molecule? And in so doing, the examiner establishes whether this candidate is going to be a 6 or a 7. For the candidate that submits very little, that student does not have to be marked down to the lowest, but random questions could be thrown out at that student to scaffold and to bring out whatever knowledge and understanding they do have of the chemistry guide, so that what might look like a 1 or a 2 could be raised to a 3, because the purpose is to assist the student as much as possible to demonstrate their mastery or whatever level they're at